Hi, everybody. I hope you guys are having a great week so far. Thank you so much for all of your feedback on the assignments to this point. I'm just going to keep taking all of those comments into advisement and making sure that we're adjusting things so that people aren't feeling overwhelmed and people are feeling like it's a good amount of work and they're getting the practice they need on the concepts we're working on. So thank you for that. Please keep it coming. What I have heard is that the word problems on the homework assignment or that final assignment for the week that's due on Friday or Monday now, the word problems are giving people a little bit of trouble. So what I'm going to do is for the word problems on the assignment, I'm going to help you guys out by drawing the pictures and kind of getting things started for you and then seeing if you can go from there. We can talk about all of these in our face-to-face meeting on Monday, but just wanted to give you guys a starting off point or a launching off point in case these were giving you trouble. So we'll get right into that. Okay, so question number 4 says that Jason and Allison are hiking in the woods when they spot a rare owl in a tree. Jason stops and measures an angle of elevation of 22 minutes, 8 minutes, and 6 seconds. At the same time, Allison is standing 48 feet closer to the tree, measuring an angle of elevation of 30 degrees, 40 minutes, and 30 seconds to the owl. If Jason and Allison are the same height, their eyes 5 feet from the ground find the height of the owl in the tree. So a couple different places where this problem is tricky right off the bat. The first thing is we've got to draw the picture. We've got to kind of visualize what's going on. And then the other piece of it is in the problem, we're given these weird angle measurements again. Just going back to right when we began trigonometry, right when we started, we talked about the minutes and seconds and converting those into decimal degrees. So that's one of the first things we're going to have to do as well. So let's start there. We've got this 22, oops, we've got this, sorry guys, there we go, 22 degree, 8 minute and 6 second angle measurement is the first one. So the 22 degrees is fine, we can leave that, but we have to change this 8 minutes, 6 seconds into some kind of a decimal. We want this to be 22 point something. So to do that, we're going to take our 8 minutes and we're going to divide by 60. We're going to take the 6 seconds and we're going to divide by 3,600. When we do those, we get, so 8 divided by 60 gives us the 0.1333, and 6 divided by 3,600 gives us 0.0017. When we add those together, that gives us 0.1350 is our decimal. So this 22 degrees, 8 minutes, 6 seconds actually becomes 22.135 degrees. So if that makes sense, go ahead and change that 30 degrees, 40 minutes, 30 seconds into decimal. Go ahead, pause the video, try that out, and then I'm going to keep going. So pause it here. If you haven't paused it, or if you're checking in, you're going to change that 40 minutes into decimal by dividing by 60, change the 30 seconds into decimal by dividing by 3,600. So we end up with 0.6667 and then 0.0083. When we put all of those together and we add them up, we've got our 30.675 degrees. So now we're dealing with degrees in a way that we know how to do it, in a way that we can put in our calculator. So that's the first part of the problem. The second part of the problem is actually drawing the picture to give us a visual as to how this problem is going to work. So the thing that we know for sure is the height of this tree. So here's my tree, which has a height of h. From there, Jason is looking at the tree from over here. So there's my right angle. Jason looks up with that angle of elevation of 22.135 degrees. Allison is 48 feet closer to the tree. So the distance from that point on our triangle at the end where Jason's standing to this point here, that distance is 48 feet. When Allison looks at the owl in the tree, who's up at the top here, her angle of elevation is 30.675 degrees. What we don't know, one of the pieces that we don't know that's really important is this distance right here that completes Allison's triangle. So I'm going to call that x. Since I've named that piece, I can refer to this triangle both by this inner triangle that is Allison's and the entire big triangle that is Jason's. Yeah, Jason's. I can refer to them both ways. So if I was talking about Jason's triangle, the blue one, we're talking about from this angle of elevation here, so this 22.135, if we're relating this base length here and height, from this angle, the height of the tree is my opposite side, and the ground, the length on the ground, is my adjacent side. So the trig function that relates opposite and adjacent is tangent. So I'm going to say that the tangent of 22.135 degrees is equal to h, which is my opposite, over, now that adjacent side is actually both of those pieces put together. It's the 48 and the x. I have to add those together to get my full base. So over the h, my adjacent side is 48 plus x. So now I have an equation that has two variables. If you guys remember when we did systems of equations back in Algebra 1, if you have two variables that you're trying to solve for, you have to have two equations. Luckily, we can make another equation using Allison's triangle, this red one. So again, we're working from this angle, this 30.675. In this triangle, the height is still my opposite side, and that x side is now my adjacent side, just x, not the x plus the 48, because now we're talking about this smaller triangle here. So now I can create another equation. I've got that the tangent of 30.675 is h over x. Two equations, two variables. This is now solvable. So it does get a little tricky with some of the distributing, and these are kind of gross numbers. They're not the whole numbers that we're used to. But from here, see if you can figure out how to find what you're looking for. Essentially, we are looking for the height of the tree, but don't forget, here's the tricky part on this problem too. We're dealing with the triangle as it is, but technically, both of these people's eyes are 5 feet above. So the height of the tree, where the owl is, whatever you find for h, you're going to have to add 5 to that. So just be careful of that when you get to it. We are solving for h though. This is what we're looking for. So you're going to be solving for h. You're looking to get rid of x and solve for h in both of these equations. And then you'll just have to add 5 to it to get the final answer. So when we have our face-to-face on Monday, we can certainly talk about all of this if you're still having trouble getting through, but hopefully this is enough to get you started. All right, and here's number 5. So number 5 reads that a drone is flying over a college campus. The drone spots the cafeteria on the west side of campus at a 27-degree angle of depression, and the sports complex on the east side of campus at a 34-degree angle of depression. If the cafeteria and sports complex are separated by a straight road 2.3 miles long, how high is the drone? So again, this is one of those that I think the tricky part is mainly in drawing the picture. So let's figure that out. I started by drawing this road in between the cafeteria and the sports complex. I think I like having that base in place, and we know that it's going to go straight across. So that's where I'm going to start. So if I start here, so now don't forget, this side is west, and then over here would be east if we were doing never eat soggy waffles. So over here on the west side of campus is the cafeteria. And then due east of that is the sports complex. And the distance between those two is 2.3 miles. Okay, now from there, we've got to put in this drone. We've got to figure out where it is and how to kind of differentiate or determine the angles that are happening between the two. So I'm going to put my drone right about here. Now, what we know of the drone is that it's spotting the cafeteria. Let's focus over here first. It spots the cafeteria at a 27-degree angle of depression. So what that means is if I take this horizontal line, that the line of sight from the drone to the cafeteria goes down from the horizontal 27 degrees. So that angle right there is 27 degrees. Now, if you remember, think way back to geometry. If we have two parallel lines cut by a transversal using alternate interior angles, we know that, this angle here is also 27 degrees. Let's see, this line, this horizontal line, is parallel to this horizontal line that we've created, and it's been cut by this transversal. So my alternate interior angles match this angle with this angle. So if we know the angle of depression is 27 degrees, we also know that this angle of elevation from the ground up to the drone's line of sight is also 27. Please let me know if that doesn't make sense to you guys, and I'll go back over it. Okay, now the drone looking at the sports complex says that it has an angle of depression of 34 degrees. So same idea here, the angle of depression is 34. Alternate interior angles means that this angle is also 34 degrees. Okay, again, let me know if that doesn't make sense, but we've got our two blue parallel lines, and then now this is the transversal connecting them. So it's this and this. I always used to think of alternate interior angles as looking like a Z, and it's the angles that are inside of the Z right here that are the same, that are congruent. Okay, so now we've got two of the angles in our triangle. We've started building this triangle now that goes here and across and then down. So there's the triangle we're looking at. There are two ways of going about finding this angle here. The first thing you could say is that we know that these three are a linear triple. All three of those are going to add up to a straight line, or 180, so we can subtract 27 and 34 from 180. Or we've got 27 and 34 inside, so we also know that we would subtract those from 180. So two different ways of looking at it. Either one is fine, but what we end up getting is that this interior angle is 119 degrees. However you want to look at it. So it says if they're separated by a straight road, how high is the drone? What we're looking for now is if we were to drop a perpendicular line to the base, we're looking for this height here. Now, couple different ways of going about this. We know an angle. We're looking for a side. Now, technically, this is a side. This H length here is either a side of this triangle on the left, or it's a side of this triangle on the right. So that being said, we can either find this side here, which is X, or we could find this side Y. We're able to do that because we have 119 degrees and we have 2.3 miles. So we have an angle across from a side, which means we have that pair that we can use for the law of sines, which is then going to allow us to solve for either this leg, the X leg, or the Y leg. Once you have one of those, again, you're going to be able to use you're going to have this side, and you're looking for this side, and we have an angle measurement. So you really have everything you need after you solve for either the X or the Y. Then you're just going to use trig functions. So I'm going to leave it there. I'm going to let you guys do a little work with that. Try to recreate that drawing on your own now that I've kind of talked through it. And then we can go over the final answer for this one on Monday. Good luck. All right, and here is number 6, the last one that was kind of tricky on this homework assignment. So this one reads that two bicyclists left at 11:30 a.m. for a ride. Rider A traveled at a constant rate of 12 miles an hour at a bearing of north 47 degrees east, stopping at 1:30 p.m. Rider B traveled until 3 o'clock, biking at a constant rate of 9 miles an hour at a bearing of south 62 degrees east. Determine the distance between the two bicyclists. All right, so again, I'm going to help you with the drawing, and then I'm going to let you guys try to do the rest of the workout on your own. So the first thing I'm going to do, because we know that each of these are traveling off of either both north and south, but in the east direction, I'm going to put in, let me move to black over here. I'm going to put in a vertical line so that I can go to the east for both bicyclists. So we've got north up at the top, east is going to be out this way, and then south at the bottom. So my first bicyclist traveled at a constant rate of 12 miles an hour at a bearing of north 47 degrees east. So what that means is we go to the north and we come out 47 degrees. So that's what that means. Since they were traveling at 12 miles an hour and they rode from 11:30 to 1:30, they traveled for 2 hours. So 12 miles per hour tells us that they're going to have traveled for 24 miles. That's how we're going to use that time and that distance. So here's bicyclist A. Rider A. And here's rider B. So rider B travels at a bearing of south. So this time we're going to come down in this direction, but we're again going to go to the east. So 62 degrees east of south is essentially what that means. So we're going to come out. We're going to pretend that this is 62 degrees, not drawn to scale. South over to the east, 62 degrees. And they traveled from 11:30 to 3, so 3.5 hours to make them have traveled for 31.5 miles. So this is rider B. Now we have our triangle. We've got A and B, and now I'm going to call our starting point C. And there's the picture. I am going to leave it there to let you guys figure out which of the laws you need to use. And see if you can fill in. We're still missing one piece of information. Think about how we filled in the drone picture and problem number 5, and see if you can fill in that last piece of information. I'll give you a clue. It's an angle. See if you can fill it in, and then you should be able to use one of those laws to find the distance between the two, which based on the way we drew this is actually going to be side C. This is what you're looking to solve for. So again, I'm going to leave it there. We'll continue to go over it if anyone needs it on Monday, but please feel free to send me any other questions you guys have. I hope this video was helpful, and I can't wait to see you guys on Monday. Have a great long weekend, and I'll talk to you soon. Bye.